Hello, in this video, I will introduce partial fraction decomposition, and I will do a linear factor decomposition. So in this section, you will learn to write a rational expression as a sum of two or more simpler rational expression, also known as partial fraction decomposition. So what is partial fraction decomposition and why is it important? Partial fraction decomposition is the process of taking a rational expression that is a polynomial fraction, and splitting it up, that is, decomposing it into simpler fractions, being the partial fraction that, when added, results to the original expression. For example, you have this rational function x plus 7 over x squared minus x minus 6, right? What you want to do is break it down or decompose it to the right side, this side, and basically you're finding this 2 is a constant and this -1 is a constant. I'll call it A and B. So that's what you're really trying to find, the A and the B constant. Why do you need to know this? Because later on in Calculus 2, you will need to know how to properly decompose a partial fraction in order to integrate a partial fraction. So this will happen in Calculus 2, and you need to integrate a partial fraction. Okay, let's move on. So there's different methods for different types of partial fraction decomposition. You have a linear factor, you have a repeated linear factor, quadratic factor, repeated quadratic factors, and improper. Here, let me show you an example for each. So a linear factor would be like x plus 7 over x squared minus x minus 7. A repeated linear factor would be something like a quadratic factor is 3x squared plus 4x plus 4 over x cubed plus 4x. A repeated quadratic factor would be like 8x cubed and then you have an improper fraction. So let's do example one, a linear factor. So let's decompose a linear factor. Okay, so let's do example one, linear factor. Write a partial fraction decomposition. Create the partial fraction decomposition of x plus 7 over x squared minus x minus 6. So what I'm going to do is factor the bottom. So x plus 7, I'll leave that alone. But on the bottom, x squared minus x minus 6, that can be factored out as x minus 3 plus 2, right? Okay, then what you're going to do is decompose it. On the bottom, these are x minus 3 is a linear factor, right? It's in the form of y equals mx plus b. So is x plus 2. It's also a linear factor. So we're going to have two different constants. So the first constant, we'll call it a. And then you have x minus 3. You just have to remember that on the bottom, it always has to be, the power on the bottom has to be bigger than the top. So this is true. So on the bottom, the highest power is x1. And then on the top, you have like a is a constant or also x to the 0. So this is very important. You just have to know that the power on the bottom the power on the bottom has to be bigger than the top, always. Okay, and then the same thing with the other factor, x plus 2, it's a linear factor, so it gets its own constant, b. Okay, so our goal in this partial fraction decomposition is figure out what the a value is and figure out what the b value is. So how am I going to do that? The first thing I'm going to do is get rid of the fraction by multiplying all sides by the LCD. So let's look at our bottom. We have an x minus 3. On the left side of the equation, we have x minus 3, x plus 2. On the right, we have this and this. So what do you think our LCD is? If you said x minus 3 times x plus 2, you are correct. Okay, so you're going to multiply all sides, all three sides by x minus 3 and x plus 2. Okay, so on the left side, what do you see that cancels? The x minus 3 and the x plus 2, correct? Everything cancels, so you're just left with x plus 7. On the right side, if you FOIL this out, what do you see that cancels? The x minus 3, so you're left with a and x plus 2. Okay, now do it on the right side, the b. What do you see that cancels? The x plus 2, so you're just left with b x minus 3. Okay, so the next step is we got to figure out our a and our b. So what you can do is plug in a value for x. Yeah, and then simplify. So I'm going to plug in that value x equals -2, because if I plug it in here, this cancels, right? And we want something to cancel. So let's plug in our x value -2. So this would be -2 plus 7. This would be -2 plus 2. And then this is -2 minus 3 is -5. Okay, so as you can see, this cancels. So on the right side, you're left with b times -5, which is -5b. And then on the left side, -2 plus 7 is 5. And then you solve for b, so you're going to divide both sides by -5. So you get b equals -1. Okay. Okay, now I know what b value is, and I also know what should I use what should be my next x value. I should use, I think I'm gonna use x equals -3. I mean +3. So I'm gonna substitute it back back to here. So it's 3 plus 7. And then my x value is 3, so it's 3 plus 2 plus b, and then my oh, we said that our b value is -1. So this is -1, and then my x value, so it was 3. So 3 minus 3. So this cancels. 3 plus 2 is 5, 5a. 3 plus 2 is 5a, and then 7 plus 3 is 8, 10a. I mean 10. Solve for a, so you're going to divide both sides by 5, and then you get a equals 2. 10 divided by 5 is 2. So a is 2, b is -1. We've solved our problem. So usually your teacher just wants the a and b value, but if you really want it decomposed, your final answer can be expressed as this. x plus 7 over x squared minus x minus 6 equals 2. Our a value, which is 2, over x minus 3, and then our b value is -1 over x plus 2. Okay, so this decomposes to this, and then if in calculus 2 you're going to most likely integrate this, and as you can see, now you can use substitution. Okay. Yeah, that is it for this section. Well, the next one will be the next example would be repeated linear function. Okay, I'm going to stop here.